This lecture is going to look at rocks, and it's going to be a survey. There's many different types of rocks, and we're definitely not going to look at them all. We're going to go through the general types here. The background picture on this slide is of the Teton Mountains up there, and that is Amphitheater Lake on a hike up in the Teton Mountains. Well, what are rocks? Rock is the most common abundant material on the earth. Just as we mentioned before, there's just almost an endless variety of rocks. Rocks really can be thought of as a mixture of minerals. And when you classify rocks, you really classify them about how they are formed. And they are divided into three basic types: igneous, metamorphic, and sedimentary. Picture in the background is some sedimentary rock, mostly sandstone, and this is a picture of the Wind River Range in Wyoming. First type of rock we're going to look at are the igneous rocks. And igneous rocks form from molten rock, which we call magma. And as we talked about earlier, if this magma reaches the Earth's surface, it's referred to as lava. The picture is magma that has reached the Earth's surface, or lava, and this is from the Icelandic volcanoes of last year or the year before. Well, as magma cools, it crystallizes, and there can be a whole range of crystallization rates here, but we're going to just look at some generalities here. If you have slow cooling, and typically when you have slow cooling, you're going to cool inside of the Earth, you're going to have very large crystals or larger crystals. If the magma reaches the Earth's surface or cools near the Earth's surface, you're going to have faster cooling, and it's going to form small crystals. The other thing about igneous rock is, which really sets it apart, is the amount of silica present. And we looked at it earlier, the silicates being the most abundant mineral group in the Earth's surface. Also, the amount of dissolved gases in the magma can affect what type of crystals you get and the type of rock you get. A lot of times this gas can be sulfur dioxide, carbon dioxide, and a water vapor. When magma hardens underground or beneath the Earth's surface, it is said to be an intrusive igneous rock. Intrusive, inside, that's how I always like to think of it. And typically when you see these types of rocks, they have a very coarse-grained texture because of the large crystals. And again, when it hardens inside the Earth's surface, it takes a little bit longer. The picture here is of some granite, and again, you can tell there's a lot of quartz in there. And there's some very large crystals here. And I took this picture in the Teton Mountains on a hike up Cascade Canyon. So when you talk about intrusive igneous rocks, those are those types of rocks that form inside the Earth's surface. The second major category of igneous rocks are the extrusive igneous rocks. And this is when the magma reaches the surface, lava, which we talked about before, and it cools very quickly. As the magma cools quickly, it only allows very small crystals to develop. In fact, this is a picture of obsidian here, and has a very glassy-like texture. And also notice the fracture on there. It's called conchoidal fracture. Kind of looks like a clamshell on there. So when you think of it extrusive, I always like to think of it as it exits from the interior of the Earth. Intrusive inside, extrusive exits. Well, rock won't always cool at the same rate all the time. It can cool at different rates at different times. You gotta remember, this cooling can take place from hundreds to tens of thousands of years. This isn't something that happens within a few days. And many times the rock can cool at different temperatures, and you can have different crystal sizes. This is referred to as porphyritic texture. The picture you can see, the top must have cooled very quickly as you have very small crystals, and then beneath it you got larger quartz crystals there. This picture was taken again on a hike in the Teton Mountains up the Cascade Canyon, and it's a great example of different cooling rates. The top part must have been right at the Earth's surface or close for those very small crystals to have formed. One of the major types of igneous rocks are the granites. And the granites are typically referred to as light colored rocks because they contain about 70% silica. Granites also contain feldspars, micas, hornblends. Hornblends will give them quite often the darker mineral in there. Granite makes up the continental crust, and the density of granite is about 2.7 grams per cubic centimeter. And again, these granites can run a whole spectrum of colors. Again, granite's been pretty popular for kitchen countertops, headstones, and there are many, many different types of granite. The other major type of igneous rock are the basalts. The basalts contain very little silica, but they contain a high percentage of this iron and magnesium rich minerals. And these minerals are really what give basalt their darker colors. Basalt type rocks make up the ocean floor. Their density is about 2.8 to 2.9 grams per cubic centimeter. And this higher density causes this basalt to sink. Hence, it forms the floor of the oceans, where the granite actually floats, and that, again, the granite is our continental crust. The second major category of rocks are the metamorphic rocks. These rocks have been subjected to high temperatures and pressures within a few kilometers of the Earth's surface. If it gets too far deep, they're going to melt and become magma, therefore it would be referred to as an igneous rock. This heat and pressure put on the slide here, it could be from mountain building activities, or the rock can come in contact with what's called an igneous intrusion, or this magma which has come from the Earth's interior, and it can heat the rock. There's a few things that can change during metamorphism. Some minerals may recrystallize, grow bigger, grow smaller. The rock may become more compact. As you put pressure on the rock, it's going to squeeze out any voids or any moisture in the rock, squeeze these crystals down into a smaller area. And again, the crystals may grow larger. But metamorphic rocks are definitely an interesting group, and we'll look at a few here on the next slide. In this slide, we have some examples of metamorphic rocks. On the upper left is slate, which is a shale that has gone through heat and pressure. Slate, if you play billiards or pool at all, slate tables. Slate used to also be used in chalkboards at one time. In the upper right-hand side is marble, which is really limestone that has undergone metamorphic processes. The marble can be used in flooring. Sometimes you see in countertops, decorative work on large buildings, and most of the world's best marble comes from Italy. The picture in the lower left corner is a gneiss, G-N-E-I-S-S. The typical geologic joke is have a nice day, and typically you can tell a gneiss from the banding on there. The picture on the right is a schist, and this schist has this shiny metallically look to it. All of these samples, all these pictures, they have very, very small crystals. And that's because as you go underneath this metamorphic process, these crystals in the original rock can get squeezed together and can become smaller. One other process we need to look at with metamorphic rocks is foliation, or the aligning of the minerals into bands due to differential stress. As you can see from the diagram on the left, as you start putting a rock under pressure, and the pressure is coming from both sides, the minerals are going to align themselves into bands, and this process is called foliation. The sample on the right is a type of gneiss, and definitely you can see the banding of the quartz, which is the white, and the feldspar, which is the pink there. So foliation, the aligning of minerals into bands due to differential stress. The third type of rock are sedimentary rocks, and these rocks have undergone a certain process. Any type of rock can be sedimentary rock if it follows this process. The rock must be at the Earth's surface so it can be weathered. Erosion will also take place, breaking the rock into smaller pieces. Weathering and erosion also go hand in hand. Deposition, the material's got to accumulate. It just can't keep moving around due to gravity or water. The fourth thing that happens is compaction. As this material settles out or deposits, it compresses the stuff that's on the bottom. It starts layering out, layering out, layering out. And then the fifth step is what's called cementation. That's where as the material compacts, minerals will work their way into the spaces between the sediments and cement or glue them together. The picture in the background is all sedimentary rock, and it's a feature known as Chimney Rock, and this is near Scottsbluff, Nebraska. And Chimney Rock was a way station, or was a signpost on the Oregon Trail as the settlers headed across west. Again, sedimentary rocks, there's a whole range of them, and in the next slide we'll look at a couple of these. Here are the three of the more common sedimentary rocks. The one on the upper left is limestone, and interesting enough, this picture of limestone has some fossils in there, and fossils can only be found in sedimentary rocks. In igneous rocks, you're looking at magma, and that would destroy any fossil evidence. And also in metamorphic rocks, the heat and the pressure would also destroy any fossil evidence. So fossils are only found in sedimentary rocks. Limestone is actually deposited by the shells of small creatures on seafloor beds, and we'll look at this in some greater detail when we start getting into the historical geology of the Earth. The sample on the right is sandstone, and you can definitely see the different layers of sand just by the different colors as they band out. And the bottom left picture is a shale, very, very fine material that has compacted over time. And these three are very common types of sedimentary rocks. This chart really breaks down sedimentary rocks into two basic categories: clastic sedimentary rocks, and these are rocks that are made from other particles that have weathered, broken apart. You can see sandstone is in there, shale's in there, and they really are classified by their sizes. If you look at coarse over 2 millimeters, you're looking at conglomerate or breccia. And on the right-hand side are chemical sedimentary rocks, and most of these rocks have fell out of solution in very shallow seas. You can see quartz in there, very fine crystalline, gypsum, rock gypsum is in there, halite. And so these are the two major categories. It probably wouldn't be a bad idea to look at this chart here and understand how it works. If you were asked, tell me the type of clastic rock which has a grain size of 1/16 to 2 millimeters, you would look on the chart on the left and see, oh yeah, that looks like it's going to be sandstone. Or if you look at the chemical sedimentary rocks and that type of rock that was made from fine-grained organic matter, and if you look at that chart on the right, you would see that would be a bituminous coal, which is a type of coal. And so again, it's a good example of a chart reading here.